Hello, today we're going to explore one of the most famous and useful ideas in all of geometry, the Pythagorean Theorem. By the end of this video, you will be able to state the theorem, identify its components in a right-angled triangle, and apply it to solve for a missing side length. The Pythagorean Theorem is a fundamental principle that connects the side lengths of a specific type of triangle. But before we get to the theorem itself, let's make sure we understand this special triangle. So what kind of triangle do we need for the Pythagorean theorem? It's called a right-angled triangle, or simply a right triangle. A right triangle is a triangle that has one angle that measures exactly 90 degrees. This special angle is usually marked with a little square like this. It tells you immediately that this is a right triangle. Every right triangle has three sides, and each side has a special name. It's really important to get these names right. First, the two sides that form the right angle are called the legs. We'll label them A and B. Second, the side that is opposite the right angle is called the hypotenuse. The hypotenuse is always the longest side of the triangle. We'll label it C. So, to recap, a right triangle has two legs and one hypotenuse. The hypotenuse is the longest side and is opposite the right angle. Now that we know the parts of a right triangle, we can state the theorem itself. It's a remarkably simple and beautiful formula. The Pythagorean theorem says that in a right-angled triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the two legs. In other words, if we call the legs A and B and the hypotenuse C, the theorem can be written as an equation. A squared plus B squared equals C squared. Let's say that together. A squared plus B squared equals C squared. This equation is the heart of the Pythagorean theorem. It describes the relationship between the three sides of any right triangle. As long as you know two of the sides, you can find the third. That's the formula, but what does it actually mean? The Pythagorean theorem has a fantastic visual interpretation involving squares built on the sides of the triangle. Let's draw a right triangle. Now, let's draw a square on each of its three sides. The side A has a square with area A squared. The side B has a square with area B squared. And the hypotenuse C has a square with area C squared. The Pythagorean theorem, a squared plus B squared equals C squared, is saying that the area of the two smaller squares, the ones on the legs, adds up to exactly the area of the large square, the one on the hypotenuse. You can think of it like this. If you could pour the area of the first leg's square and the area of the second leg's square together, they would perfectly fill the area of the hypotenuse's square. It's a powerful and concrete way to visualize this abstract mathematical idea. Let's put the theorem into action with our first example. Suppose we have a right triangle with legs of length 3 and 4, and we want to find the length of the hypotenuse. So our legs are A equals 3 and B equals 4. The hypotenuse is C, which we need to find. First, we always write down the formula to keep it fresh in our minds. A squared plus B squared equals C squared. Now, we substitute our known values for A and B. Next, we calculate the squares. 3 squared is 9, and 4 squared is 16. So we have 9 plus 16 equals C squared. Adding the numbers, we get 25 equals C squared. We're not done yet. We've found the square of the hypotenuse, C squared. To find C itself, we need to do the opposite operation of squaring, which is taking the square root. The square root of 25 is 5, so the length of our hypotenuse is 5. This triangle, with sides 3, 4, and 5, is a very famous example of a right triangle. Notice that the hypotenuse, 5, is indeed the longest side. That example was easy because the answer was a whole number. But what happens when the answer isn't so clean? Let's try another example. Imagine a right triangle with legs of length 7 and 9. What is the length of the hypotenuse? Again, we start with our equation. A squared plus B squared equals C squared. Substitute the leg lengths. 7 squared plus 9 squared equals C squared. Calculate the squares. 7 squared is 49, and 9 squared is 81. Adding them gives us 130. So we have C squared equals 130. Now we take the square root of both sides. The hypotenuse, C, is the square root of 130. This time, the answer is not a whole number. 130 is not a perfect square. How do we find its value? This is where we use a calculator. The square root of 130 is approximately 11.40. So we'd say the hypotenuse is approximately 11.4. Remember, the hypotenuse should be the longest side. 11.4 is indeed longer than both 7 and 9. Always check your answer to make sure it makes sense. So far, we've only solved for the hypotenuse, but the theorem is powerful enough to find the length of a missing leg too. Let's say we have a right triangle where the hypotenuse is 10 and one of the legs is 8. We want to find the length of the other leg. We know A equal 8, C equal 10, and we're looking for B. Our trusty formula is a squared plus B squared equals C squared. Substitute the values we know. 8 squared plus B squared equals 10 squared. 8 squared is 64, and 10 squared is 100. So we have 64 plus B squared equals 100. Now we need to solve for B squared. To do that, we need to get it by itself. We can subtract 64 from both sides of the equation. This gives us B squared equals 100 minus 64, which is 36. We're almost there. To find B, we take the square root. The square root of 36 is 6, so our missing leg has a length of 6. Let's check our answer. The legs are 6 and 8, and the hypotenuse is 10. Is 6 squared plus 8 squared equal to 10 squared? That's 36 plus 64, which is 100. And 10 squared is also 100. It works. Let's summarize what we've learned today about the Pythagorean theorem. First, the theorem only applies to right-angled triangles, which have one 90-degree angle. We learned to identify the parts of a right triangle. The two legs, A and B, which form the right angle, and the hypotenuse, C, which is the longest side and is opposite the right angle. Then we learned the theorem's formula. A squared plus B squared equals C squared. This equation describes the exact relationship between the areas of the squares on the sides of the triangle. And finally, we practiced using the formula to find missing side lengths, whether it's the hypotenuse or one of the legs. You now know the basics of the Pythagorean theorem. It's a foundational concept in geometry and is used all over the place, from construction and navigation to video game development. Thank you for watching, and keep practicing.